Indian Express for agent-based programming for banking domain. He has publications in 9 national conferences, 12 international conferences, and 14 international journal and 2 edited book chapters. He also has publications in 40 Scopus Index publications. He also has published a book on C++. He is a reviewer for Elsewhere Computers and Electrical Engineering Journal and many more. He is also guiding scholar with Amrita Vishwa Vidyapeetham in area of video analytics, deep learning, signal processing. He also teaches courses in video processing, video analytics, distributed systems, multidimensional signal processing. He is also part of funded projects with IBM, DST, and Ministry of Tribal Affairs Multi-Coreware. Sir, we welcome you and thank you.
So you can log in now.
Yeah, so thank you for the good introduction. Am I audible?
Yes, sir. You're audible.
Okay, now I'll share the screen. Thanks to Sujata ma'am, thanks to the principal, deans of the campus to have chosen me to interact with your students. And good afternoon to you all students. So can you see me at least a good afternoon? Can you acknowledge me? Yeah, thank you. Okay, I will share the screen. Just acknowledge me if you're able to see the screen. Sir, you able to see the screen? Hello? Sir? Hello?
Is it audible, sir?
Yeah, it's
I can
audible
see.
to me. Yeah, okay, right.
Yeah.
Thank you. So without wasting time, let's step into the topic. So, so the topic I would take you through is on how AI is more into innovation today. We look at AI everywhere. There is innovation of AI coming up in the products. So we look at the thought process first. So first, what we need to know is like what are the backbone of AI. So when you look at AI, people will start defining AI as in the way in which you can make computers work, in the way in which we human beings think. So we are trying to make systems or machines which can work as like humans. But all that can happen only when you are trying to make some learning to the systems. So that is done by using some algorithms. So there are many algorithms in principle. So we have K-means clustering, which is compulsory everybody should know if you want to come into AI or deep learning. Then you should know AdaBoost classifier. So it's an example of a boosting classifier. Then you should know CNN, which is convolutional neural network, right? So now, when somebody says what is K-means clustering, then first question you would ask is, what is a cluster? Okay. For example, if you ask yourself what could be a cluster, I would go back to a simple example of a paint and I would say that, okay, let me start drawing some clusters. So I just pick some dots. Now each one of this that I put here is a cluster. Okay. Now I would say all of this fall into one cluster. Now somebody says, what is other cluster? I would actually go in and say, okay, all this are the other cluster points. I would take this, put it under a different cluster. Now what is this clusters? They have some characteristics because they have red color. They have something called as green. But you can see something which is clusters which are falling outside this, which is very much outside, which we call it as something called as outliers. So the keyword I'm introducing to the people is today many people around the research or in the product development are facing some challenges regarding this keyword. How to identify outliers? Okay, so outliers are very important to every problem. So when you say outliers, the outliers are in the context of the problem, right? Now let's look at this in a more practical perspective. Somebody wants to walk through this algorithm and start discussing, then person would say that I can actually use the k-means clustering. Now somebody is looking at k-means clustering, the next keyword would be k. Now the advantage of k is like you can actually start with clusters as much as you want, and you can reduce the clusters if you want, and you can combine the clusters wherever required. So this is a strength. The weakness is like it's very simple. So the challenge is like what is K, right? Now, for example, now you go back to this simple one where we started. We ask you how many clusters you have here. You would say one, and somebody would say two, right? So this is one, and I'm just saying the second cluster has two, right? So there are two clusters for my example. Now somebody would actually say that, okay, why don't you say this as one and two? You can actually take everything together and put it under one cluster, right? Now, for example, if you look at your class, you would say it's a class. Within the class, I have girls and I have boys, right? Okay, so I call it as one cluster. So the cluster as such is saying that there are two more clusters within that. Now look at this and start asking possible examples, right? What you can define around, then there are plenty of examples. Now let's see some examples. Suppose you take a crowd, right, of people who are actually trying to travel, right? So I'm just going behind internet because so that you catch up with some thought process. I just say, okay, I just want to have some images of crowd of people. Now let's take you look at this crowd of people. Okay, let's look at this one. A very complex example, right? I look at this cloud of people. I'm interested to ask a couple of questions in this. One question I would ask is like, okay, can I identify a person X? Okay, can I identify a person X here? Somebody would say, okay, you identified X, then I just want to know, is it crowded or not crowded, right? Crowded or not crowded. So this is the normal question that we would ask. Now, where is this useful, right? So here, let's give a thought process. Okay, just for understanding for people. Let's take you are walking in such a crowd, right? And you happen to search for a person who is going far behind, who is your father or your mother. So maybe I would like to have a camera which would say, okay, your father is 10 steps away, your mother is 10 steps behind, right? So now what I would be interested to do is I'd be interested to detect the person, right? And I would be interested to identify the person. Okay. So this is where AI is coming up like anything, right? Today you have cameras, you've got connected cameras for most of the applications. So if you go down and say AI for crowd identification, right? So you will get a lot of work which people are doing around the world. You can see here, right? I'm just taking this one because it's very popular URL. So here they are using AI actually to find information related to the crowd, right? So this is your sample test image, right? So they are interested to have some approaches, and then they want to come up with what is the density of people who stay there. Okay, so you can look at a problem from your perspective. In this, you can identify a person. Somebody might identify how many people are having umbrellas. Okay, so a crowd management system is your perspective. You can actually decide and move as you want. Now let's go from here and start asking the discussion from the algorithm perspective. Now, this algorithm says, okay, you need to fix the value of k. Now people assume that k is your choice, right? So you can have it as 2, 3 as you want. So what a k-means algorithm would do is like this. It will say first, give me what is k, right? If I say 2, then it will say I will randomly select some cluster hits and I will start grouping the clusters, right? So as it starts grouping the clusters, it would be able to say that, okay, this is one cluster, this is another cluster. How is it doing it here is it is taking one of the sample data here, and one of the sample data here is 650, one of the sample data here is 200. With that, it is trying to say something less than 650 is one cluster, something less than 200 is another cluster. Okay, so you can randomly choose your cluster seeds. It's up to you, right? For example, if you ask me an example for a real case, right? Now let's take a company is coming for placement. Let's call the company as X, Y, Z, right? So if I say I'm looking for CGPA between, right, 75 to 90. So you would say one cluster seed is 75, other cluster seed is 90, right? So let's take you take the same scenario to another company called as UVW. Now here this company says I still look for a CGPA, but my thought is different. I just want to look for CGPA from 70 to 90. So one seed is 70, other seed is 90, right? So the factors of fixing seed is basically from the context of the problem. So your problem context can actually say what can be the seed value that you want to provide. Now, if you take it here, you will be able to understand what is seed. Okay, so now each one of you, when you look at your problem, you should look at and start asking what is seed. With the seed value, you can fix your clusters. Now, a k-means clustering would actually say you want to calculate the distance of each data with respect to the seed value that you've taken, right? For example, if you go back to the scenario that I told, okay, so I can just start asking, okay, there's a roll number, his roll number is 101, his mark is 73, right? So in that case, you will say 73 is not close to 75, right? Somebody would say, okay, let's take 102, mark is 87, then you would say 87 is closer to 90, right? So because it falls in the range. So every time when you want to compare a data point with the seed value that you've taken, right, you can actually use some distances. So the popular distance you would use here is Euclidean distance. The popular distance you would take up here is an Euclidean distance. So now somebody would be curious to understand, okay, what are you talking about these distances, right? Is it so important? You go to internet and type Euclidean distance, right? You would see the formula for Euclidean distance, and you can actually see the other differences from Euclidean distance versus other distances also. So if you ask a question, okay, can you say what is the other distance that is there? Then this is from image processing perspective, right? There are some distances called as Manhattan distance, Minkowski distance, all that. So this is actually the possibility to look at comparing a data from one seed point to another. Now, the thought process goes better. Now people will ask yourself, okay, when I look at every data, I'd actually look at the distance. Based on the distance, I'll try to see whether it's close. Now from where we started, the seed value 1, seed value 2, we're looking at every data and we are checking how much it's closer to the seed. So here you would actually look into an Euclidean distance and you would try to say this is one cluster, this is another cluster. Okay. Now once you've done it, now the natural interpretation somebody would ask is, okay, this is cluster 1, this is cluster 2, but there's something different in the middle. So what should I do? I should go and change the seed, right? So what is the possibilities? Like I can take a new seed value. With that, I can check all the points and see how much it's closer to the cluster. So this keeps repeating. You will get a final point where all the objects, all the data points fall into the respective clusters. And that is the point you will assume that your k-means is being fixed. Now here the challenge in k-means clustering is usually when you look at k-means with Euclidean distance, right, sometimes it doesn't work good when the data is of a nominal type, right, and sometimes you need to do a rescaling of the data also. So all these are issues when you go for the k-means clustering, right? So what each one of you should have got at your mind is a quick thought process of what k-means is. Now let's look at a couple of other examples to keep it fancied or understanding, right? So I'm just going to internet. I'm just showing you an example of like this. So I'm just saying how to classify fruits, right? Because everything is automated. So now, for example, I have a set of fruits with me, right? Like this. I would be interested to know, okay, can I classify the fruits? So here there is an architecture which is called as FruitNet, which people should know, right? Which actually looks at classification of fruits. So if you come down, you'll be able to get an understanding about what this approach is. So the data set as such, they have looked at three type of fruits: good fruit, bad fruit, mixed quality fruit, and they are trying to say that the classification is good. Now, where is this useful? If somebody is having a question, where should I use this, right? See, today when you're going for exports, right, we should understand that Many of the products from India gets exported, including the fruits. So if you want to have an automation for it, which is already in place, which says that, okay, given a tray, I'll be able to classify the fruits correctly. There you have AI in place. So that is where artificial intelligence work. Now you have seen about k-means clustering. Now I want you to know one more algorithm in which is close to AI, which is called as boosting algorithm. See, what is this boosting algorithm is, it says that if you have some data and you would like to classify the data, why did you have different learners, right? So what is this learners would be is like you ideally fix some rules, and based on the rules you try to classify the data. So if you go to k-means, we said our rule was to go into Euclidean distance, but when you go for boosting, we look at learner, and based on the learner rule we try to combine the learners and see how do they work, right? It's a very popular approach. You won't believe, even today most of the problems are being solved by using boosting classifiers, right? Now how does this work? It is like this. It says that if you have different learners, each learner can use different algorithms, each learner can use different features, each learner can concentrate on different subproblems. So finally, it means that the boosting classifier that you have created is better or intelligent to classify the data correctly, right? So how does this work? It is like this. This is the person who's introduced this. You can see the year 1995. We are in 2022, 27 years after. But still, if you see AdaBoost, most of the approach or researches are carried out with AdaBoost classifier, right? So even now AdaBoost is very popular. Now the outline of AdaBoost classification goes like this. We look at possibly creating weights. This W you can assume it as weight. So okay, so every time we combine it to create a hypothesis which expands as y suffix m of x is equal to sine of summation of small m to capital M alpha m ym of x. Okay, now this takes care of the approach like this. First, we look at the weighing coefficients. This weighing coefficients is what you call it as W, right? Second, what we do is for m value from 1 to capital M, we look at fitting a classifier. So this classifier will be fixed by using the notation y suffix m of x. This is your y suffix m of x. So we find a high classifier to which we can fit this data. Now every time you check the error function which is j suffix m. So don't worry about the mathematics behind. So the idea would be like the AdaBoost classifier will every time evaluate a quantity called as epsilon suffix m, and using this it will calculate alpha suffix m. So you see two parameters, epsilon suffix m and next is alpha suffix m. This is what you can see under this alpha suffix m. Okay. Now there will be surely mathematics in AI. Without mathematics, there is no artificial intelligence for all the information. Now let's look at considering how an image can actually understand. Now, if I ask you, this is a bigger image, this is a smaller image. If I ask you what is unique, somebody would say, see, this is a very unique feature, right, of this bird. So this unique feature is what we call as patterns. This unique feature is what we call as features, right? And here when you look at features, you'll have two names. One is called as low level feature and next is called as high level feature. Color is a low level. It's black, brown, gray, all that is low level feature. This is a high level feature because it's got a shape, right? Now you take as much as features that you want and you try to apply with an activation function, right? Then what you can able to do is you will be able to detect the beak. That means this part. Okay, I'm just giving you a small thought process. Now somebody would ask me, okay, why do you learn or why do you need to detect birds? So that's a lot of interesting research which is happening in birds. In fact, my team of students work on the similar problem. So let's take, you look at bird detection, okay, with audio, right? detect bird detection with audio, you can see here they have developed approaches through which they detect the birds. And if you go to Kaggle also, there's a good data set which has got birds audios. Now, if somebody has got an audio of birds, with that you can recognize what bird has come to your place. And second thing is, it will be helpful to the environmentalist to understand which birds are rare birds which has come to that place. So there's a lot of research going into this bird detection. Now this is a good side, okay, of a bird detection problem. The other side of bird detection problem is, which you should also know, dangerous birds. Okay, dangerous bird detection, right? So we are interested in knowing, can we detect dangerous birds? Okay, there also people work. Why is this research on dangerous birds is they won't spoil the fruits. I think you know that sometimes in television you would see birds have come to the farm and it has spoiled the vegetation there because it is all dangerous birds. So we need systems which can actually detect the dangerous and scary birds also. So here also people work research. Now if you connect this slide, you will understand and accept, okay, if I have a bird image, I need to detect what type of bird. For that I need a model. Okay. Now when you look at detectors, now if you see this is one of the detector of this bird. This is combined. We are able to say, okay, this is beak. You take this, now you combine, you say the beak is there in the middle, not in the top, right? So you can learn as much as you want from the data, right? Now the other one which everybody is talking nowadays today is on artificial intelligence, machine learning, deep learning. Then everybody wants to do projects, research in deep learning, right? So let's quickly get into this architecture. See, this architecture is a very primitive architecture, which we call it as CNN, which is called as convolutional neural network. So how this architecture works is, it says that I can have convolution layers. What is the purpose of this layer, right? Now, if you connect to the previous one, what do you want to detect? Beak, upper beak, middle beak. Somebody would say lower beak also in other one. I would like to take all that and develop a filter for it. So given an image, I would like to detect the beak, and then immediately I want to say I have detected a beak here, right? So that's where convolution layer works. What a convolution operation would do like this is this. This is your image, right? It's a 6x6 image. Now, if you have filters, so filter 1, filter 2, right? If you apply a convolution, then what happens is every filter will apply on the data. Now, this is my filter 1. So I'm superimposing this filter on this 3x3. When I apply, what happens is it's a dot product. So how does it does the dot product would be like this. It says 1 into 1 plus 0 into minus 1 plus minus 1 into 0 plus minus 1 into 0 plus 1 into 1 plus minus 1 into 0 plus minus 1 into 0 plus minus 1 into 0 plus 1 into 1. It will give you 3. Like this, it gets repeated. Okay, so we can move the filter to the next column because stride is 1, right? Again, it does a product. So again, if you say stride to be as 2, this is how it works. I move the filter first on the first one. Since we said stride equal to 2, it will shift 2 columns right. That means, please have a look here. So I'm shifting 2 columns right. That means I should shift here. So automatically it will shift here, right? Now again, the filter will be multiplied with this 3x3. You will get a resultant one which you'll provide it here. Now this is how your convolution operation and stride operation works. So this goes continued as you can see here. So we move over the entire uh, image, we get a final output, right? So this is with respect to image, how a convolution and a filter operation works in the case of CNN, right? Now we we will do this for all the filters, right? So what are we saying here is, if you have a doubt, okay, what I'm talking, it's like this. This is where we started our discussion. Our discussion was, we have an input image, we have two filters. We should take this first filter on this, second filter on this. Every time we'll get a resultant image that will indicate a feature map. Okay, this is one feature map. Now when I take filter 2, take it over the image and repeat over the entire image, I will get a new set of values which is called as feature map. Okay, so this process will repeat again and again. Now this, what we have shown is actually for a grayscale image. Now somebody takes a color image, then you would say I need a color model. Your color model may be an RGB model. So it'll have red, green and blue, 3 color channels. So red, green and blue. Now when I look at the image, I'll have one channel for red, one for green, one for blue. Then when you look at the filters, I'll have filter 1, filter 2. Same process. The filter will be applied over the input image and you will get a picture map. Now in this, when you actually look at the next layer, which is a fully connected layer. So what is this fully connected layer here would be, is like all input data would be participating to the output. As you can see here, all inputs x1 to x36. Why do we say x1 to x36 is this is 6 cross 6 image, so totally you have 36 values. So all values from 1 to 36 will actually participate to the output, right? So that's why we say it is a fully connected one. Okay, now you can see here all inputs will participate in the output. So we call this a fully connected. Now let's take this example here. This is a 6 cross 6 image. You have a filter 1, you apply, you get an output. Now you get the values. Fine. Okay, so this values will be again connected to the value that you get after doing the convolution. So the first value after you do the convolution is 3, right? So here, now all inputs are connected to the output. Okay, so if you still have a doubt, just try to understand. This is 1, 0, 0, 0, 0, and so on. It means row wise. We take the values and put, we connect it to the convolved output, right? So if you would like to extend this, you can extend it for all the values after convolution. Now when you do this, what happens is the weights that is come for the learning from here would also contribute to the learning here also. So that's why we call it as a shared weights, right? Now this is a small example for a CNN. If somebody says I want to develop a model to detect animals, cat, dog, right? So you would say you have some convolution layer, you have a pooling layer, and you get an output. You can stack as many number of convolution, as many number of pooling layers. So as you can see here, convolution with pooling, we get a final output. Okay. So next, somebody will ask a question: what does pooling does? So pooling as such will, what it will do is it will take the maximum values and it will give you the output. So this is your result after convolution. Okay, with filter 1, it takes 2 cross 2 takes the maximum. So every 2 cross 2 it will try taking the maximum. So now here you will get 3, here you will get 0, here you will get 3, here you will get 1. Okay, 3, 0, 3, 1. Same here, it will be -1, here it will be 1, 0, 3. Okay, so this is the resultant after you do filter 1 and filter 2 with the pooling. So in summary, it's like pooling as such will take the maximum value out of the convolved inputs and it will give you the output. So why is pooling important, right? It's very important to understand. See, you when you do pooling, you can see very well that the size of the image is coming down. right? So originally your size of the image was like this. Now it has come down like this, right? But this is also important to be done because you can understand that when you do a image processing, you do a subsampling of the image processing, it will remain the same. This is a bird. After you do a subsampling, it's still a bird, right? So pooling is very important for the problems. So you can have CNN as a model solution for any type of problems. So what generally happens is, if this is an image, it's given to convolution, given to pooling, you will get a final output image. Now, the next one which I want people to understand would be is like, sir, am I audible? Please, can you
Yes, sir.
acknowledge? Yeah,
Yes,
okay,
sir. Yes, sir.
right, okay. Now, see, when you all start doing something like this, you will start getting a question, okay, what is that I would like to attack in AI? Okay, so if you go to internet and see AI innovation, okay, this is not fixed because what is there today is changing tomorrow. If you can see here, you can actually see the 10 latest innovations that is hosted by different labs, right? So this is one of the innovation which is being hosted, which is called as intelligent process automation, right? This says that you take any unstructured data, you will create unstructured data for it, and this is part of the RPA, that is a robotic process automation. In healthcare, many people are looking at healthcare as many problems. For example, we want everything to happen in the smartphone. If I open my smartphone app, even my smartphone app can say that, okay, what is my temperature, or do I have any symptoms of fever, like that. Third area which is projected is AI with IoT, that is Internet of Things. Today, IoT has become very popular. So students who want to work can actually now try to take an area and start working with IoT. In future, many of the applications will run in IoT, right? Then AI in smart money. So here they are trying to understand that can we use systems which are based on NLP, natural language processing, to understand how money investment can happen around the business owners, right? AI in automobiles, I think people know connected cars. When you're driving, you can actually have a connected car mechanism and you can actually have autonomous driving. So AI in automobiles is also coming up. Then AI for virtual assistants and chat box, right? For example, I go and open a website, right? Let's take for example Access Bank, right? So I just go here. I'm interested in doing some operations with customer care. Okay, so let's say I go here and I start clicking on this. This is just for information, right? So here, if I happen to see something called as a chat, yeah, so you can, this comes from the other side also. I'll just show you. I'm just showing you some examples, right, where a bank chat, chat support, right? Yeah, just see here. So for example, I go here and I just provide my details and I start chatting. There'll be a chat bot which will come up and interact with me. That will solve most of my questions what I have. I did not talk to a phone banking officer. That is a place where now people are trying to attack. So can you have systems which will actually try to give some sort of support back to the users in terms of chat boxes, right? Then AI in processors, this is becoming very different. So practically, I don't know much, but reality, what people say is like low cost processors, right? Especially in terms of computers, which will have powerful algorithms to run, right? So next is quantum AI. This is more related to something called as quantum computing, right? And AI for cybersecurity. In fact, with cybersecurity, I can comment. I have a funded project with IBM where we look at how artificial intelligence can be used for understanding malware threats in networks, right? So AI in cybersecurity is coming up, and this is also coming up area, robotic process automation with AI, right? So this is something which you should also follow up, students especially, to know, okay, what is the state of AI, right, in the future. Now, we have gone through that, then the next question somebody would ask is, okay, I also want to do something. Where shall I start with your applications or programming side, right? So here, when you look at any problem, right, every problem that you look at actually has more than one perspective. Somebody would say, I'm trying to have a desktop solution. Somebody would say, no, no, whatever I did in AI is actually a network solution. Somebody would say, no, no, it's not network, it's a web solution, right? Somebody would say, no, no, it is a mobile application, right? So things goes like this. People look at solutions from different perspective. It can be desktop, it can be network, it can be web, or it can be a mobile application. Whatever it is, today the answer would be like people generally, I'm not promoting any platform. People generally have a natural advantage to go towards Python because Python is taken as one of the universal tool. So what I say to the people would be like, if you're trying to do something, then you can install Anaconda, right? And you can start coding things in Python. It is not very new. I think most of you would be knowing this. Now, when you do this, then the next question somebody would ask is, what framework can I go for? So here you can go for Keras, right? Keras is a very good framework for doing the code. So you can look at Keras for doing the code here. The next one that you can go for would be is like you can actually go for Tiano. Tiano is also a good framework for coding AI. Then next one is which is available is TensorFlow. TensorFlow is also a good framework for doing programming. So there are plenty of frameworks, right, for people to code and experiment. Now comes a tricky question. People usually will ask like, which one should I use? Which is best? Okay, here, to my knowledge, you know what I would suggest use like whatever you take. For example, if somebody says, I would like to do a face detection application, right? Just go and see, okay, what is there with face detection with latest, and has that somebody published something in face detection in GitHub. So you would get some code, right? So you can take any face detection code which you like. There's nothing like this is good, that is bad. If you happen to say that your application is good or bad, then the answer would be like it mostly depends on the type of data set that you've taken. So just if you're very worried about the data set, please go to the data set and build your own data sets also. So this is a request I'm keeping to the community of people who want to work in AI. So here, the summary which you should take from here is like you should actually concentrate on the data set. When you concentrate on the data set, please make sure few certain keywords. What is a positive samples? What is negative sample? This lot of people miss in the beginning, so I'm just showing you this in the what is validation data, what is positive, what is negative, what is validation data. So what is positive, what is negative, what is a validation data would be like somebody says your face, it is a positive sample, right? Somebody says I'm just having a non-face, right? It's a negative sample. So in this, you can assume it's like this. If you have 100 images, right? So people generally look like this. If you have 100 images in positive samples, you can take 70, right? Negative samples, you can take 10. Validation, you can take 20. So playing with this number is your interest. You can say 75, 10, and remaining to be given as validation also. But make sure that you are trying to look at data set creation as a first step. It is very important for all your information. Now in this, you should understand that there's a very popular architecture which belongs to the field of deep learning, which is called as GAN architecture. So my request to the audience would be is like, if you are looking at anything in deep learning, please always look at this architecture also, generative adversarial network. It's a very good architecture to generate data and check whether your data samples are correctly validated or not. Now, once your architecture is done, then most of the things have been solved. So there, somebody would ask, okay, I am developing something in AI. How do I go and evaluate that model? So this is a small example. So it is a UI which is there on the internet. So these are all features. These are all neurons. Okay, you can add as many number of hidden layers to this, right? You can see what is the ratio of training testing. So I say 70% is training, 30% is testing. If I'd like to add some noise, I can add noise. I can see batch size, right? Batch size is, you are saying in your total data, you want to split it into how many batches. That's information here. Once you've done it, you can specify something called as learning rate, activation function, regularization, regularization rate. You can click classification. These are all called as hyperparameters. In terms of deep learning, these are all called as hyperparameters because this is supplied by the user, right? The developer can actually say what are the values as hyperparameters. What is estimated is parameters. This is a parameter 1, this is a parameter 2. So here you should understand loss is a common keyword. So loss indicates a difference between the expected minus actual. So here if you can see, there are three keywords that we were trying to say. One is positive, negative, and next is validation, right? So you can estimate your loss in terms of this data set also, or you can estimate your loss in terms of training, testing, and validation. Now the question is, how long should I run? When I click, I can run. So it keeps on running. The point at which my loss value has got reduced, at that point, I can go and I can stop my model, right? Now, the question somebody would ask is, if the data is so large, it takes more time to run. Okay, so I cannot run it on my computer. So that is where people look at taking support of GPU. Right? People look at taking support of GPUs. So if you have a GPU system, then you can actually make use of it, as your professor was informing in the beginning, right? If you have some good proposal, you can take some funding so that you can request for a funding for a GPU. So the advantage would be is the system will give you high scalable performance. So the output also will be very better, right? So my suggestion to the people is you can look at having a GPU, or if you feel that no, there is other possibility of getting an online account, then you can go to the Colab, right? And you can try to access your code in the Google Colab, right? So there your system, your code is going to run on the Google Colab. Here again, from our experience, what we know is like sometimes the Colab also will not give you better performance. It'll ask you for a premium account. So there, if your institution supports, you can actually take your Colab institutional account. Okay, you can try getting a Colab institutional account of you. Advantage would be is like you can run code for more amount of time and you can get better results. So I'm just leaving an information to the participants. So here when you come to Google Colab, it's very simple. This is your Colab environment. Now I say I want to open a new notebook. There's some existing code. I can open the code, okay, and I can run my code also. If there's a new code that I want to create, I can go here and I can click on new code, right? So my suggestion to the people is start doing things parallelly, right? One side coding, other side data set, other side you keep your system. Your output will be very much clear, right? Now in this face recognition, there is a very popular architecture called as deep So here you'll find an architecture called as FaceNet, right? FaceNet architecture. And see, please take it from me, right? This is face detection, though it is a very solved problem, still it has got a lot of scope, right? For example, as I was saying, if I have a crowd of people and I would like to know who is the person standing there, right? Who is the person standing here? Then still the person who is at the back, is not very clear to me. There, people can actually look at possibility of going for face detection to be better. That means you can improve the face detection problem and try to make it solvable for any type of problem. For example, you have a camera in the bus, right? And you want to detect all the faces. And once the bus says yes, all people are boarded, bus can start, driver can start, right? So it's a face detection problem, right? So there is a lot of data, but only thing is we do not have autonomous evaluation of the data. So my request to the people would be is like you still have an option, like as you can see in your auditorium who are all sitting. It is possible for the system to say what is the person sitting here, why is this person bending down, why is this person's emotions not okay. So it can still go to the data and say this person looks to be sleeping, right? And this person is completely slept, this person is listening. So it can go to every piece of data and it can say something interesting about the data. So data is a very important part when you're going for artificial intelligence. Now, people would be curious to ask, okay, what is that we have done, right, with my team? What we have done, I'll show you that also, so that it gives you an interest. So we have attacked one problem, which is fault detection recently with AI concepts. So the objective was like we want to develop an architecture which can actually have real-time prediction. So here we want to monitor people, and we were looking at a healthcare environment. So it's very challenging because if you can see here, no, if this is a fault detection problem, I'd like to have this fault detection problem here. I'd like to have this fault detection problem here also, right? Now the research gap is like there's a lot of research has been done, but still there are architectures which can be developed. So we thought we can go for a transformer architecture in terms of fault detection. So these are all the possible data sets that are there on the internet. Okay, and these are all the samples. So in each sample you can see whether it's a fall or not a fall. It gives a context of the gender, whether it's male or female, how many people are there, how many cameras are there, how many faults are there, right? So we looked at a data set called a CMD fault data set to check this model. So we looked at some papers also. So each papers, for example, paper 1 gave us a data set called as LE2I data set. Paper 2 suggested UR fault detection data set. Paper 3 suggested DST fault detection data set and NTU data set. And paper 4 suggested data sets with kinetics. Each data set gave us an approach they have used. So you can see here, paper 1 used a fall motion mixture model. Paper 2 used an open post model. Paper 3 used a spatial transformation graph. Paper 4 used a vision transformer graph. Okay, so these are the metrics that I used: accuracy, precision, recall, and they have used one more metric called as G-flops here. The drawbacks were is something like this. So they used traditional ML algorithms. Second thing, the prediction accuracy was not very high. So what we thought is we will come up with an architecture for it. So our architecture is like this. So we want to have a vision transformer model which will actually take the frames and it will try to do the prediction. So the prediction here is like this. We want to predict whether it's a fall or not a fall. So generally, if you look at this transformer architecture, it has got multi-head attention models together with MLP for prediction. So this is a general thing. So if you have any input data, we can develop a self-attention model. So the self-attention model will try to understand the relationship with its individual features, right? So these are the metrics that we were looking at: loss, accuracy, precision, recall. So this is a very common metric which you can also use if you're going for AI for developing any product. The development environment we used is this. System is Intel Core i5, RAM is 32 GB, GPU is Tesla, code was written in Jupyter, language is Python, TensorFlow is a library, OpenCV stands for Open Computer Vision Library. So this is the results of different runs. So I would be happy to show you the results in output. Now if you can see here, there's a person lying down. You can see the status, it's not fall. As a person falls, our system will say the person has fallen. Okay, you can see here, label is non-fall. When the person falls, the system will say immediately the person is fall. Second, is a person standing. Originally it is not fall. When the person falls, system will say the person has fallen. Look at this, it's not fall. Person falls, it's a non-fall. This is from our lab. So person is trying to fall. It says immediately the person has fallen. Okay. So originally it is non-fall. It says immediately the person has fallen. This is from our product team. We are developing a fall detection system which is completely on AI based to know whether it's a fall or not a fall. Some of the things that we work um, is into possible solutions of developing solutions for yoga. So we are also trying to look at how yoga can be found with its corresponding feature. Okay, so our requirement is we just want to find a feature corresponding to the yoga, what the person is doing. So next is something which we are trying, which students will not like. We want to have a human activity recognition for finding out whether somebody is copying in the exams. Okay, so our requirement is like this. If you see here possibilities of copying, somebody raises hands, somebody is showing some fingers to the student here. Okay, so you can see a red symbol around. This is ROA. This says immediately the person is trying to copy. This person is showing lifting the hand. This person is trying to move the fingers. Now this is architecture. So we want to take a live video. We have done it in the class. You would like to extract the features. Here we are taking support of image processing algorithms, which is hair feature. I just spoke to you about ADA Boost. We have used ADA Boost here also. And we want to take hand gestures also, right? When somebody is trying to point something to the other person. So gesture estimation is also done. We want to classify whether it's a normal or suspicious activity, right? We have used an algorithm called as Euler-Jones also as part of results. So this is how the system goes. So as the person sits in the classroom, all faces are detected. Okay. So this is again, in this case face is detected, this case face is not detected, and we have got some good results with this. So this is what we are trying to do with respect to AI. So building AI applications is not the important one first. You should see a social care for it. So there are many places like even I was saying to my team, can I actually have um, yeah, a product which can actually take care of childcare, right? Childcare, if you see here, you see many places, you can see child beaten by servant, right, at home. You hear such incidents, right? Servant at home. Okay, so is it possible that can I have some camera which can actually send a message whenever my child is being beaten by the servant? So there also there's a lot of AI requirement there. So you can think of AI everywhere. So wherever there's a social place, you can also look at AI as a one possible solution. And people usually have a question like, when you build application, can I do a real-time processing? Because most of them will do offline processing. I have data in the camera, but I cannot process. But please understand, for example, if this is an IP camera that you're streaming, right, of each one of you can write a code to process the live data from the IP camera. So whatever we have shown here, right, all this are results from our IP camera. Okay, live. Okay, so our IP camera can detect somebody standing, falling down. So please don't stop at a point where it is only offline data. So my request would be used to take everything as much as online and see how much systems can be better. Future products I'm hearing from industry says they are developing a multimodal system for classroom assessment. For example, there's a camera facing to each one of you. Like that, there can be a camera facing to me. For each of my content that I say, how many of you listen? Based on that, it can give a score back to me, right? So there's a classroom assessment system which companies are working on. So that's it from my side, and thank you so much to Sujata ma'am and the institutional members for the opportunity provided. Any questions from your side, please? Sir, am I audible?
Yes, sir. Yes.
Yeah, I see a silent scene in front of me. Any questions from the audience? Okay, there's no questions from my side. Then I would actually say one thing. Learning is when you involve yourself in knowing something from the discussions and so on. If you would like to work with me in my research labs here in Amrita, so please you can write a mail to this ID. You can write a mail to my official ID also, just for tracking your mail, and you can work with my research projects that are ongoing. This is my mail ID for your reference. So any clarifications from the audience, your side, please? Sir, sir, am I audible?
Yes, sir. You are audible, sir.
Yeah, okay, fine. Any
Okay, sir.
clarification?
Thank you, sir.
Yeah, okay. Okay, thank you all. Thank you so much for the patient listening. So I'll leave
Okay,
here,
sir.
sir.
Okay, sir. Thank you. Thank you so much, sir.
Thank you.